Assalamu alaikum everyone. How are you? I'm fine. Today I will discuss how to analyze and design a isolated footing using site software. Okay, let's go. To analyze and design of any foundation, we need to follow some steps. Following are the steps. First of all, we need to calculate the column reaction under which we need to design the footing. We can calculate it by manually or by using any finite element software like ETABS, StatPro, SAP, or any other finite element software. Here I will discuss since I have calculated the reaction using ETABS software. That's why I will discuss how to export the column reaction from ETABS and import it into SAP software. Then let's go how to export the column reaction from ETABS. Here is my record building where I will design the footing. First of all, I will show the column support or reaction. Here I am showing the column support reaction as service load as WSD load. Here I will select this column under which I have to design the foundation. Here the footing column reaction is 449.8987 if among these total dead load is 366 and total live load is 83. First of all, I will co collect the total column reaction. That means, okay, I am showing the total total dead load here 366. Now I will use an Excel Excel to calculate the approximate size of the footing. Here by using the allowable bearing capacity we can calculate the allowable approximate size of the footing. Here I have created a Excel calculation to calculate the size of the footing. Here total dead load total live load is 80. Total live load is 83 and total dead load is 366. Okay, 83 366. Okay, total load is 449. Okay, and now I will insert the bearing capacity under this footing. Okay, this is the soil bearing capacity which has been tested for this building. Here the allowable bearing capacity is 5.31 ksf. Allowable bearing capacity is 5.31 ksf. Okay, here I will put 5.31 ksf. Okay, then my column size is here. I'm showing this column only. Okay. Okay. My column size is 24 by 24 inch. Okay. Here my column size is 24 by 24 inch. Since it is in the foundation level which is covered by uh, soil, so I will increase the column size here 3 inch 2 inch. Okay. 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 So column size is 26 by 26 inch. Here my required uh, and here my required footing size is, okay, let's see, the soil pressure, soil weight above the footing is 10 footing, and the weight of the footing is 10%. So I can add 10% load into 10% load. Okay. Our total total footing size required is 93 feet square. So if I use the square size footing, then I need 9.64 by 9.64 feet footing. If I use 10 feet by 10 feet footing, then it is okay. Okay. Here I will put here 10 feet by 10 feet. Okay, my footing size is 10 feet by 10 feet. Okay. Okay. Now from here I have collected the load and calculated the footing, approximate footing size. Now I will draw a footing, single footing. Okay. The footing size is 10 feet by 10 feet. Okay. Left edge is 5 feet, 5 feet. Okay, 10 feet. And upper case 5 feet by 5 feet. Column size is 26 by 26 inch. Column square size I have also is column size square size, and dead load is 366, where live load is 83. Live load is 83. Okay. Then footing thickness, approximate footing thickness is I will change this footing for checking the bearing capacity, punching shear. By checking the punching shear, I will change this footing thickness. Okay. And subgrade modulus. I will calculate the subgrade modulus by using the allowable bearing capacity. Here the allowable bearing capacity is 5.31 kSF, and now the subgrade modulus will be equal to 12 into factor of safety. Here the factor of safety of this footing, allowable bearing capacity is 2.5. Here 2.5 allowable bearing factor of safety has been used to calculate this allowable bearing capacity. Okay. The allowable bearing capacity, uh, 2.5 is the factor of safety, and the allowable bearing capacity is 5.331 equal to, if I calculate this, okay, then 159.3 159.3 keep per keep per feet to per feet. Okay, this is my subgrade modulus. Okay, I will put this value here. The subgrade modulus is in pounds, so if I make this value, okay, then 1.53593 into 10 minus 5, it will 10 5 the pound per feet square per feet. Okay, 1.593 into e to the power 5. Okay, this is my required size and all the input has been done. Okay, now I will save this file. Okay, I will save this file in tutorial isolated 14. Now I will analyze it. And another thing I have to mention that this subgrade modulus is this subgrade modulus is calculated for 1 inch settlement. Okay, this calculator is on in settlement. If my calculated settlement is more than 1 inch, then it is not safe. If the settlement is lower than 1 inch, then it is okay. Here now I will display Ippon shape reaction. Okay, here first I will take the load combination. Here first one is 1.14, second one is 1.2. I will create WSD for deep load 1 and live load is 1, and this is for service condition. Okay, date live. Okay, now I will check for okay, display action dot combination. What is this? Okay, first of all I will default, then again. Okay, before analyzing any starting any analysis, I need to automatic match to load transfer. Right, it is 4 feet. I can change it to lower value. Lower value will give better result. Sorry, I will take it 1 feet. Okay, now this is here. I will check the settlement. Okay, this is settlement deform shape WSD. Here the settlement is 0.337. Settlement and found from analysis is 0.37 inch. Which is less than 1 inch. Okay, safe for settlement. Okay, another check is I need to check the maximum developed stress, and this stress development must not be greater than larger than the allowable bearing capacity. Okay, the reaction soil pressure for FSD is my allowable bearing capacity. My allowable bearing capacity is 5.31 KSF. Develop develop bearing capacity soil pressure is 4.961. 4961 pound PSF, pound per square feet, equal 4.91 KSF, which is less than 5.31, KSF allowable, which is allowable bearing capacity. So the foundation is adequate. The foundation size is adequate for the allowable bearing capacity. Okay. Now I will check the punching shear. Okay, then and it is need to be clear that punching shear must be calculated for ultimate load, but the bearing capacity must be checked for service load, that means WSD load. Okay, punching stress here, the bearing capacity. Okay, the punching shear is 0.75. Here develop punching shear ratio is equal to 0.75, which is less than 1. 1 is allowable ratio. So the thickness of the footing is adequate. The thickness has been used as 24 inch, but I can take the footing thickness for lower thickness, for using by using lower thickness. Okay, I can use this as 24. No, I can use this as 20 inch. Here I have used 4000 psi concrete capacity. Okay, for 24 inch I can take it. Okay, that here the capacity here the undeformed here 3.75, and the reaction 4.94956. That was the previous one was 491. 49 has been reduced. Okay, now the punching capacity checking. Here the punching shear capacity ratio has been increased from 0.75 to 0.999, which is almost equal to allowable capacity. So we can use punching footing thickness as 24 inch. Okay, 24 inch. Okay, now I will show how to design the reinforcement of footing. So design, for design I will select the tension for 5 tension control 0.6 as per ACI 31808. 0.9 and compression 0.6175. Minimum cover is top clear cover. Okay, here the footing size it is contract with soil, so clear cover will be 3 inch, 3 inch, 3 inch. Okay, prepared by putting number fiber. Mm, okay, I have no beam, that's why I will not change this. It is not affect the design. Okay, and load combo, here I will not design for this. I will just design for this portion. Okay, then I will remove this. Then design and display the design result. Slab design result. Here I will show strip based result. Strip based result. Sorry, I will finite element based result and strip based result. Since I have not selected any strip, that's why I can only um, use the finite element result. But if um, I can define the strip here. Edit, add design strip. In x-axis A, in y-axis it is B. Okay, I have defined two strip. Now I can check the footing reinforcement. Here I will tick mark the impose minimum reinforcement. It will show top river and bottom river. Okay, in layer A. Here I can see that only bottom river. Here the bottom river is 0.5184 inches square per feet. Okay, in y direction in y B layer in y direction it is also maybe same, because the footing is square size, so the reinforcement will be same in the both direction. Okay, here if I want to design for check it for lateral load, that means wind load and earthquake load as per BNBC. As per BNBC, we need to if we want to check the bearing capacity pressure, allowable bearing pressure. If we want to check the developed footing pressure for lateral load, that means for wind or earthquake load, then we'll we can increase the bearing capacity by 30%. That means if we want to use the lateral load for checking the footing, then we can use subgrade modulus as equal to 1.33 into this one. If we want to use the want to check the bearing capacity or footing for lateral load also, then we can use this value of subgrade modulus. That means that bearing capacity can be increased by 33%, and we can check the footing bearing capacity, footing punching shear, and the reinforcement of the footing also. uh, I think uh, I hope cleared all the things about the about designing the um, isolated footing. And today it is all for designing an isolated footing using a software, uh, using a safe software. Thank you very much for watching this. Assalamu alaikum.